right, here we go. Today we are going to talk about the inverse of a square matrix. All right, but in order to determine an inverse, we need to know what an identity matrix is. Okay. An identity matrix is always square, okay? And it consists of ones along the main diagonal and zeros everywhere else. Okay? So a 3 by 3 identity matrix looks like this, and we call it I. Our identity matrix we usually name I for identity. Well, if you put this in an augmented matrix, this is the left side of reduced row echelon form, right? And we'll talk about that here. Not today, but later. Okay. An identity. Okay, what's the multiplicative identity with real numbers?
No. You switch it around so you can know.
Multiplicative identity.
Mm-hmm.
And then like anything times 1 is itself.
Itself. Anything times 1 is itself. Anything times the identity matrix is itself.
Oh.
Okay? Notice though the identity matrix is square. Okay, we're talking about square matrices. Okay? But an identity matrix works like the number 1 does in multiplication with real numbers. All right, so let's talk about what an inverse is. Okay. When you think of an inverse, throw out some things that come to mind with real numbers.
Yeah.
Fractions. Why fractions? Okay, so what is the inverse of 2? Okay, what's 2 times 1/2?
1.
1, and we just talked about 1 being the multiplicative identity. We're talking about real numbers. 1 is our identity, right? 2 times 1/2 is the identity. So when we talk about an inverse matrix, we're talking about an inverse. When you multiply it to A, you get the identity back. Okay? Kind of like real numbers. 2 times 1/2 is 1. I take a matrix times its inverse, we're going to get the identity matrix. Okay? Notice how we're still working with square matrices. A non-square matrix will not have an inverse, and there are some square matrices that won't have an inverse. Okay, so having an inverse is special. First of all, you need to be square, and still there are some times where there won't be. Okay, so I'm going to show you 2 ways to find the inverse of a matrix. Okay, and eventually I will show you how to do it on your calculator. can let you borrow mine. Everyone good? Okay, so we're going to find the inverse of this matrix using the knowledge we have about what an inverse is and how to multiply matrices. Okay. We know that A times its inverse is what? Okay. Is the identity. Okay? And we know that this is a square matrix, right? Alright? So, this is X in the first column, first row. This is X in the first row, second column. Okay? You want to choose different letters than that?
No,
Is it okay?
yeah.
Alright. Alright, so what do we know about multiplication? We do row times column, and that equals whatever entry, correct? So we know that 1 times x sub 1, 1 plus 4 times x sub 2, 1 should equal what?
Would be 1.
1, because it's in the first row, first column. Okay? If I take first row, second column, I get x sub 1, 2 plus 4x sub 2, 2, and what should that equal?
1.
0, first row, second column, first row, second column. Okay? Second row, first column, I get negative x sub 1, 1 minus 3x sub 2, 1, and what should that equal? And then second row, second column, negative x sub 1, 2 minus 3x sub 2, 2 should equal 1. Now we have a system of equations to solve. We have 2 of them that equal 0. Right? So could we use those maybe with substitution to help us? No? Look over here. X sub 1, 2 is going to equal negative 4x sub 2, 2. Right? How can we use that to help us? Plug it into this one, right? So we have negative the new x sub 1, 2 minus 3 x sub 2, 2 equals 1. Right? I asked if you wanted me to pick different letters. You said no. You were okay with it. Okay? Oh, that's not what I wanted to do. Sorry. Alright, so now, if this is 1, let's plug it in back here. And what's x of 1, 2? Negative 4. Okay? You can do the same thing to the other two, correct? Right here, I'm going to move this to the other side, so negative 3 x sub 2, 1 equals x sub 1, 1. Right? So if I plug that back into the top one, I get negative 3 x sub 2, 1. I'm going to replace x of 1, 1 plus 4 equals 1. So what's my coefficient? Okay, so if I plug that back in up here, what's x of 1, 1? So our inverse, what? There's our inverse.
So there's a pattern between, it's like the same numbers as the first one.
There is somewhat of a pattern. This is not the most efficient way. Okay?
Calculator.
Okay, obviously the calculator is the most efficient way, but a 2 by 2 matrix we can find by hand more efficiently than this way right here. This is possible, but this could get messy, right?
Yes.
Okay.
So 20 by 20.
Here's your magic formula. If A is the square matrix ABCD, this is only 2 by 2. We're only doing 2 by 2 by hand. Okay? Then our inverse, okay, I'll let you write it down and I'll explain my shortcuts for how to remember it. Okay, so first of all, the way I remember this right here, AD minus BC, Chris minus cross. AD minus BC.
First and cross of scientific term there.
Yep. Chris minus cross. If you want an easy way to remember it, I'm trying to help you. Okay. Then what do you notice about the numbers in here?
They're
Flip or negative.
Okay, along the Chris we switch.
Yep.
Along the cross we negate. Okay? So 1 over Chris minus cross, and then we switch and negate. Okay? So here we switch and negate. Alright? So this is actually going to be a scalar that we will multiply through. Okay? So we're going to find the inverse of this guy. Okay? So 1 over Chris minus cross. What's our Chris product? Right, 3 times 2. Here's Chris. Minus cross. What's that product? 2. Times. We are going to switch. And then negate. Alright. What's our scalar? 1/4. So when I multiply 1/4 through my matrix, we get 1/2, 1/4, 1/2, 3/4.
Wait, what did you say?
Pretty incredible.
I just multiplied this through. I just multiplied 1/4 through. Okay, so now what's going to happen if I take this matrix I just wrote in blue times our original matrix? We should get the identity. Okay, so 3 times 1/2 plus -1 times 1/2.
Negative 1/2. Oh, it's
3
14.
times 1/4
3/4.
plus -1 times 3/4.
Negative 3/4. Oh my gosh.
Negative 2 times 1/2
Negative 1.
plus 2 times 1/2.
2. 1.
Negative 2 times 1/4. And 2 times 3/4.
6/4. That's too hard to simplify. Wow. That was incredible.
Okay.
Wait, so if you use a formula, then that doesn't guarantee that it's the inverse. Is that correct? Like if I use the, because you said not all of them have a inverse.
Oh, you're 5 seconds ahead of me.
Oh, all right.
Okay. You are 5 seconds ahead of me. Because what happens? Okay, we want to find the inverse of this matrix. What happens when we take Chris minus Cross? We get our Chris product is
6. Oh,
minus our cross product is
0, which is undefined. That's incredible.
okay. We have 1/0. We cannot divide by 0. So in this case, no inverse exists. Here's your rubric.
All right.
So you don't have to check it.
You don't have to check
So
it.
like, if it works out, I don't have to like check it and make sure it equals the, and then, right?
If
Works,
you-
it always equals it.
Yeah, if you did your math correctly, okay, if you want reassurance and you want to make sure it equals the identity, that means you got it right. But okay, if you do everything right, you should be fine.
Okay.
All right. Calculators.
Feel it. Every no.
Okay.
You write down the steps for me.
We're going to find the inverse of this matrix. In order to do that, okay, I've already taught you how to input a matrix into your calculator. Okay. To get the inverse, okay, the -1, but the -1 as a superscript, that means inverse. So you'll call up your matrix and take it to that -1 superscript. That means you're finding the inverse. Okay? If there are decimals, I've taught you how to change it from decimal to fraction. I want fractions.
Well, you do the second.
Where's what?
Oh, you just push that, and then you push the x -1.
Okay? Because you should be calling up, if you enter it in A, you'll call up A. And this is what it should look like in your calculator when you press enter. The matrix button.
Where is it?
It's the button you press for second matrix. But you don't press it.
So,
I chose it and pushed this.
Okay, you can put because it's a you guys get it over here? Over here? No?
Oh.
All right. Now, why do we need inverse matrices? how could they be of benefit to us?
They're not.
It's you want to get
We can use an inverse matrix to help us solve a system of equations. Okay, I'm going to show you yet another way to solve a system of equations.
Thank God.
Okay, so write these down. Okay, now instead of making an augmented matrix, we're going to create a matrix equation where we are going to create a matrix of the coefficients our unknown matrix. Okay, why did I do this? When we multiply a 2 by 2 matrix to a 2 by 1 matrix, that's possible, right?
Yeah.
Okay, we would take row times column, 18x plus 12y. Oh, I'm not done yet. Okay, 30 plus x, 30 times x plus 24 times y. That's what we have over here, right?
Right.
That should equal the 2 by 1 matrix of 1323. So we have our coefficient matrix times our unknown matrix equals our constant matrix.
Always up to the left. If there's left or right.
You're gonna read left to right.
Let's say there was Z, then we put X, Y, Z.
Then you would put x, y, z down, correct? Okay. Remember, when you multiply the coefficient matrix with your unknown matrix, you should get what you have right here. Okay. So basically, what we have is A times X equals B. Right, in matrix. I just in matrices. I just named them A and X and B. Right? Now, if I wanted X by itself, okay, we don't divide by matrices though, right? Okay, let's go back to our real numbers. If I had 2x equals 4, instead of dividing by 2, we could multiply by 1/2. We could multiply by the inverse. Okay? So that's what we're going to do here. To get rid of the A matrix and move it to the other side, we need to multiply by the inverse. Now this is very important. Since I'm multiplying it on the left,
What's the bill on the right?
it needs to go on the left over here as well. Okay? So then what's A inverse times A? The identity. The identity times x is x, and we'll get x by itself, okay? So this is what we need to do with our matrices. All right? So, what do we need to find? We need the inverse of A, okay?
Wow.
So, what is Chris minus cross?
Let's see. I
Okay,
think it's 432.
minus cross times switch and negate. So we switch 24 and 18. We negate 30 and 12. So what is 432 minus 360? 72. So 1/72 times 24. 1/3. 1/72 times negative 12. Good. 1/72 times negative 30. Change it to a fraction. 18 over 72. So there's our inverse, right? So to find our unknown matrix, we are going to take the inverse of A. So this is the inverse of our coefficient matrix, and we're going to multiply it by our constant matrix, which was 13, 20. Ah. Okay. Now the fun begins, right? 1/3 times 13
13/3.
plus 1/6 times 23. Okay. Negative 5/12 times 13 plus 1/4 times 23. Okay. 13/3 is the same thing as how many six? 26 sixths. So we get 3/6, which is 1/2. 23/4 is the same thing as how many 12? Okay, so negative 65 plus 69 is what? 4. 4/12 is? Okay.
Can you go through like what we did again?
Yeah, hold on. What were we looking for?
X and Y.
X and Y. So the coordinate in which these two lines intersect is 1/2, 1/3.
That could just eliminate Y from stuff.
Why don't we just look at like, why do we do this?
Because we're learning.
Okay.
Three different strategies.
Because we're learning.
Okay, it is nice to have options when solving something. In the case of solving systems of equations, we have how many, like 5 different methods now?
Yeah.
Okay? Eventually, you'll be able to pick whatever you want to solve it. Okay? It's nice to have lots of tools in our toolbox. Okay? Let's talk about what we did. Alright? A times X equals B. We set up our constant matrix times our unknown matrix equals our coefficients times our unknown equals our constant. Alright? Now, to get just xy by itself, we needed this inverse. Okay? So we found the inverse. So to get rid of this A matrix, we had to multiply the inverse, but we had to do it on the left side, which means we have to do it on the left side over here as well. So we took our inverse times our coefficients, or our constants, excuse me. And we multiplied those, we got x is 1/2, y is 1/3. Okay. Now, if the inverse is nice, this is pretty speedy. Okay. Now with a 3x3 matrix, I am not teaching you how to do those by hand for an inverse. So if you get 3 variables, 3 equations, you can find your inverse with your calculator and multiply with your calculator to get x, y, and z. Okay? All right.
Use like more help for like if you're using a calculator for the
Let's do it one by one.
answers like for multivariable.
Yeah, multivariables, your calculator is going to be a lot more helpful. Okay? Okay, here's your homework. Anything that is a 2x2, you must do by hand, including these systems of equations. Anything that is a 3x3, you're allowed to use your calculator. I did not teach you how to find an inverse of a 3x3 without a calculator. But the 2x2, they must be by hand.